Hello everyone. On this video we will be looking at solving one variable linear equations. Okay, and some of those involve one step and others may involve multiple steps. Okay, so starting off, we're going to look at the fact that addition and subtraction are opposite operations. Okay, and I'll show you what I mean by that. So let's say, for example, we can honestly say that 3 plus 5 is equal to 8. Okay, so 3 plus 5 is equal to 8. So if 3 plus 5 is equal to 8, that means if we go the opposite way and subtract 8 minus 5 is equal to 3. Okay, so let's say if we say that 7 minus 4 is equal to 3. Again, if we go the opposite and then add, since we're subtracting here, if we go the opposite and then add, 3 plus 4 is 7. Okay, so that's what I mean by opposite operations. Okay, and we could also say the same thing for multiplication and division. Multiplication and division are opposite operations. Okay, so for example, let's say we know that 4 times 3 is equal to 12. Okay, so we multiplied here. So if 4 times 3 equals 12, then 12 divided by 3 is equal to 4. Okay, so again, what if we have 28 divided by 4 is equal to 7? So that means 7 times 4 will equal 28. Okay, so that's what I mean by opposite operations. They kind of balance each other out. They're related, but they're opposites in a way. Okay, so now we're going to use the fact that these are opposite operations to solve our linear equations. And we're going to use the following steps. Okay, and again, if you have a method that works for you, feel free to use that. But this is just a process to kind of help you get going. Okay, so when solving one step, one variable equations, if it is an addition problem, you're going to use subtraction to solve it. If it's a subtraction problem, then you're going to use addition to solve it. Okay, so you're going to use the opposite. Also, if it's a multiplication problem, you're going to use division to solve it. And if it's a division problem, you're going to use multiplication to solve it. Okay, so you're always going to use your opposite operation to solve it. All right. So if you are still writing, of course, feel free to press pause and finish up. But we're going to go ahead and move on to our next page. Okay. Now, also, I want you to note that integer opposites also equals 0. So if you have 3 plus a negative 3, that's going to be 0. If you have negative 7 plus a positive 7, that's going to be 0. If you have a negative 5 plus a 5, that's going to be 0. Okay, so that will always come into play when solving linear equations. All right, so let's look at the following problems. Let's say for problem A, we have x plus 4 equals 28 and x minus 4 equals 28. For problem B, we have r minus 10 equals 42 and r plus 10 equals 42. And for problem C, we have y plus 14 equals 32 and y minus 14 equals 32. So you want to solve for the unknown variables. Okay, so let's look at problem A. Okay, so we have x plus 4 equals 28. Okay, so if we have x plus 4, we're going to use the opposite operation to solve it. So we're going to use minus 4. But whatever you do to one side, you have to do to the other side of the equal sign. So we have minus 4 on both sides of the equal sign. Okay, so remember up here, when you add together your opposites, it equals 0. So if you have plus 4 or positive 4 plus negative 4, that's going to equal 0. So those two cancel out. So you have x plus 0, which is just x, so you can kind of cancel that out, is equal to whatever's on this side of your equal sign. So 28 minus 4 is 24. Okay, and what about x minus 4 equals 28? Okay, so same thing. If you have a subtraction problem, you're going to use the opposite operation. So the opposite operation of subtraction is addition. So that means you're going to add 4 to both sides of the equal sign. Okay, so if you have negative 4 plus 4, just like up here, we have negative 7 plus 7 is going to equal 0. Negative 4 plus 4 is 0, so that disappears. So your left side, you have x plus 0, which is just x, is equal to 28 plus 4, which is 32. Okay. So as long as you remember to do the same thing to both sides of the equal sign, you'll always be okay. Okay, so let's look at problem B. We have r minus 10 equals 42. Okay, so since this is a subtraction problem, you're going to add 10 to both sides, where these two cancel out to be 0. And okay, so that gives you r on the left side is equal to 42 plus 10, which is 52. And if you have r plus 10 equals 42, it's an addition problem, so you're going to subtract 10 from both sides. And those two will cancel out. That gives you r equals 42 minus 10, which is 32. All right, so let's scroll up and let's solve problem C. Okay, so what I want you to do is go ahead and press pause, and you solve these two problems for C on your own. All right, so I'm assuming you've paused it and worked it out, so let's go ahead and verify your answer. We have y plus 14 equals 32. So since this is an addition problem, we're going to subtract 14 from both sides, where those two will cancel out. So the left side of your equal sign is just y is equal to 32 minus 14, which is 18. And let's try our y minus 14 equals 32. Subtraction problem, so you know you're going to add 14 to both sides, and these two are going to cancel each other out. Okay, so on the left side of the equal sign, you have y is equal to 32 plus 14, which is 46. Okay, and again, if you have this over here, do not be afraid to just go over to the side and go 32 plus 14. 4 plus 2 is 6. 3 plus 1 is 4. This is not a mental math competition. Your goal is to get the right answer, not try and do it all in your head. So if you have to do it on the side and solve it, take those couple of extra seconds to do it on the side and solve it. It's better than trying to do it in your head and you don't have enough practice to really be able to do it in your head. I still mess up trying to do mental math. So doing it on the side on paper is totally okay. All right, so if you are still writing, feel free to press pause and, of course, finish up. But we're going to go ahead and move on to our next page. As soon as I can get this separated. Here we go. Okay, so now we're going to look at reciprocals. And reciprocals is really just flipping a fraction or a whole number. Okay, and I'll show you what I mean by that. Okay, and we also know that a number times its reciprocal is equal to 1. Okay, so for example, we know that 1 over 7 and 7 are reciprocals. Okay, well, how is that? Remember that the whole number 7, we can rewrite that as 7 over 1. So that means that 1 over 7 and 7 over 1 are reciprocals. Okay, it's literally just flipping them. Okay, so what if you have 3 and 1 over 3 are reciprocals? Okay, so if we look at that, we know that 3 is equal to 1 over 3. So 1 over 3, 3 over 1, sorry, I'm thinking ahead and making mistakes. It's 3 over 1, sorry. So 3 over 1 and 1 over 3 are reciprocals. 3 over 1 and 1 over 3 are reciprocals. Okay, so what if we have 12 and 1 over 12? Same thing. They are reciprocals. And again, 12 is just 12 over 1. So 12 over 1, you flip that, you get 1 over 12. Okay. So how else do we know they're reciprocals? Of course, a number times its reciprocal is equal to 1. Okay. So if we multiply 7 times 1 over 7 is going to equal 1. If we multiply 3 times 1 over 3 is going to equal 1. If we multiply 12 times, instead of 1 over 12, what if we make it x over 12? These two will cancel out and we'll just equal that x. Same thing here. These two cancel out and your answer is just 1. These two cancel out and your answer is just that 1 up there. But if you don't have a 1 up here, these two will still cancel out. And you'll end up with whatever's up there. Okay, so let's say, for example, if we have 5 times y over 5. Okay, these two 5s will cancel out and just equal 1. So your answer is whatever's up here, which is just y. Okay, so this will make will be very important moving forward when we do our multiplication and division problems. Okay, so just in case you're answering why these cancel out, I'm going to do one and show you why. So let's say if we have 5 times y over 5. Just a quick explanation. Remember, 5 is the same as 5 over 1. So we have 5 over 1 times y over 5. Okay, so when we're multiplying our fractions, we can go ahead and just multiply the numerator or the top values and the denominator or the bottom values. So this is just going to be 5 times y. I'll just put that up here. 5 times y over 1 times 5. So instead of 1 times 5, we're going to make it 5 times 1. Remember, multiplication is commutative. You can move multiplication factors all over the place. So instead of 1 times 5, we're going to make it 5 times 1. And any number divided by itself is just 1. So that leaves 1 times y over 1. So 1 times anything is just that value. So you have y over 1, which is just y. But you don't have to do this every time. You literally, if you have two numbers being multiplied or two factors being multiplied, you know, the whole number and that denominator is going to cancel out. So you don't have to go through this step every time. All right. So if you are still writing this, feel free to press pause, but we're going to go ahead and move on to our next page. As soon as I can separate these sheets. There we go. Okay, so let's say for problem A, we have 3 times x equals 12 and x divided by 3 equals 12. We have 7 times x equals 35 and x divided by 7 equals 35. And we have 2 times x equals 16 and x divided by 2 equals 16. So remember, we're always going to do the opposite operation. Okay, so for problem A, you have 3 times x equals 12. Okay, so if this is a multiplication problem, you have 3 times x, you're going to divide both sides. So you're going to do the opposite. So since we have multiplication, we're going to divide both sides by the coefficient or the number next to the variable, which is 3. Okay, and we know that 3 divided by 3 is equal to 1. Okay, so that gives you 1 times x, which is just x, is equal to 12 divided by 3, which is 4. Okay, and we have x divided by 3 equals 12. Okay, so we have a division problem here. So the opposite of division is multiplication, so we're going to multiply both sides by 3. Okay. So we saw before that these two will cancel out. So you have 1 times x, which is just x, is equal to 12 times 3, which is 36. Okay, so let's look at B. We have 7x equals 35. Again, it's a multiplication problem, so you use the opposite operation, which is division. So we're going to divide both sides by the coefficient 7. So 7 divided by 7 is equal to 1. So 1 times x is x, and that's equal to 35 divided by 7, which is 5. Okay. So, and we have x divided by 7 equals 35. So since we have a division problem, we're going to multiply both sides by 7. Where we know these two cancel out and we equal 1. So you have 1 times x, which is just x, is equal to 35 times 7, which is 245. And again, you don't have to do it in your head. If you want to, write it out on the side. 35 times 7. 7 times 5 is 35. 7 times 3 is 21. Plus 3 is 24. So you can just do it right on the side. Again, you don't have to try and rush and do it in your head. All right. So let's look at problem C. So for what I want you to do with problem C is I want you to go ahead and press pause and do those two on your own. All right, so I'm assuming you solved problem C. So let's go ahead and verify. You have 2x equals 16. Again, we have a multiplication problem. So we're going to divide both sides by 2, where those 2 will cancel out. So you have 1 times x, which is just x, is equal to 16 divided by 2, which is 8. Okay. And we have x divided by 2 equals 16. Okay. So since we have a division problem, that means we're going to multiply both sides by 2, where these 2 will cancel out. So you have 1 times x, which is just x, is equal to 16 times 2, which is 32. All right. So if you're still writing this, of course, feel free to pause it and finish up. But we're going to go ahead and move on to our next page, which explains how to solve a one-variable linear equation if you have more than the 1 steps that we've been using so far. Okay. So your first step is you're going to combine your like terms on both sides of the equal sign if it's necessary. Okay, so that means you're going to combine like terms on the left side of your equal sign, and then you're going to combine all the like terms on the right side of your equal sign. Okay. Now your second step, again, if it's necessary, move all the variables to one side of the equal sign and the constants, or just the numbers, to the other side of the equal sign. Okay. And then you want to simplify, well, I guess solve will probably be the better word. Solve for the variable using the addition, subtraction, multiplication, or division methods we just went over. All right. So let's go ahead, and if you're still writing these down, of course, press pause and finish up. But we're going to go ahead and jump to our examples. Okay. So let's say, for example, we want to simplify and solve 3x minus 2x minus 5 equals 7. We have 6 equals 2y minus y plus 4. We have negative 27 plus 7 plus n equals negative 5 plus 8. And we have problem D, which is 5 times 8 minus 13 in parentheses equals x minus 1. Okay, so let's look at problem A. We have 3x minus 5. 3x minus 2x. Sorry about that. 3x minus 2x minus 5 equals 7. Okay, so remember your first step. You want to combine all the like terms on the left side and right side of your equal sign. So that means we're going to combine these two. Okay. So 3x minus 2x equals 1x. Because remember, 3 minus 2 is 1. So 3x minus 2x equals 1x. And 1x is just x. So 1 times x is just x. So we can leave it as x. So these two combine to give us x minus 5 equals 7. Okay, so we don't have anything else we can combine right now on the left or right side. Okay, so now we can go to the second step, which is actually in this case the third step also, where we're going to move all the variables to one side and the constants to the other. So if we move the constant to this side, we'll already have it solved. So if we have x minus 5 equals 7, of course we add 5 to both sides, where those two will cancel out. Okay, so that gives us x is equal to 7 plus 5, which is 12. All right, so let's look at problem B. We have 6 equals 2y minus y plus 4. Let me clean up that y so it doesn't look like anything else. There we go. Okay, so again, we can combine these two. because 2y minus y is the same as saying 2y minus 1 times y. So 2 minus 1 is just 1, so 2y minus 1y is 1y. Or 1y is just y. Okay. So again, we have 6 on the left side of the equal sign is equal to 2y minus y is just y. We already figured that out. Or 2 minus 1 is 1, so 1y, plus the 4 that's still there. Okay. So just like the one before it, as soon as we do step 2, we're actually already done. So there's no step 3 after that. Okay, so if we have y plus 4, we're going to subtract 4 from both sides. Okay, where those two cancel out. So on the left side of the equal sign, you have 6 minus 4, which is 2, is equal to, on the right side, you just have your y. Okay. So the y doesn't always have to be on the left. Sometimes it'll appear on the right. Same steps. Okay. So for problem C, we have negative 27 plus 7 plus n equals negative 5 plus 8. Okay. So first, again, we're going to combine the like terms on both the left and the right side. So for this one, we can combine those two, and on the right side of the equal sign, we can combine those two. So we know that negative 27 plus 7 is equal to negative 20. And we know that negative 5 plus 8 is equal to positive 3. So negative 27 plus 7, we know this is going to be negative 20 plus n is equal to positive 3 from our negative side, negative 5 plus 8. All right. So just like before, we have negative 20 plus n equals 30, equals 3. We have a negative 20 on this side. That means we're going to have to add 20 on both sides. We have a negative 20 plus 20 is 0, so that disappears. So you have 0 plus n, which is just n. And that's equal to 3 plus 20, which is 23. Okay. So we're running out of room for D, so I'm going to do that on, continue that one on the next page. Okay, so if you're still writing this, feel free to press pause and finish up. But we're going to go ahead and continue problem D on the next page. Let me separate these. And that's the next set of example problems, so we're going to cover those up and continue with problem D. Okay, so you have 5 times 8 minus 13 is equal to x minus 1. Okay, so with this one, remember you're going to do your order of operations, but since it's only really 2 of them, you don't have to go through all the steps if you don't want to. You're going to do what's inside your parentheses first. So we know that 8 minus 13 is negative 5. So this becomes 5 times negative 5 equals x minus 1. Okay. So we have 5 times negative 5, which is negative 25, is equal to x minus 1. Okay, so we've combined all of the terms on the left. Now all we have to do is move that 1 over here by adding 1 to both sides where those two cancel out. Okay, so once we do that, we have the left side, so negative 25 plus 1 is negative 24, equals our x. All right. So if you are still writing this, of course, feel free to press pause and finish up as always. But we're going to go ahead and move on to our last set of examples. Oh, almost dropped there. Here we go. Okay. Actually, we have a few more. Okay, so let's say, for example, we have, say, 5 times 2x equals 80. 3 times x times 5 equals 60 divided by 2. We have 5x minus 3x equals 30. We have negative 14x equals 168. And we have 15x minus 10x equals 95. Okay, so let's say for problem A, 5 times 2x equals 80. Okay, so 5 times 2x, that's the same as just saying 5 times 2 times x equals 80. Because these are just all multiplied together. So we can go ahead and combine these two numbers. 5 times 2. So 5 times 2 is 10. So that gives us 10x on the left side. That's equal to 80 on the right side of the equal sign. Okay. So if we divide both sides by 10, anything divided by itself is just 1. So that gives us x is equal to 80 divided by 10, which is 8. Okay. So if we look at problem B, it's the same thing. You have 3 times x times 5 equals 60 divided by 2. The left side is just 3 times x times 5. You have 3 times x times 5 equals 60 divided by 2. Let's move that up some. Okay, so we can simplify both sides of the equal sign because we can multiply the 3 and the 5. Okay, so 3 times 5 is 15, so the left side would give us 15x. And the right side, 60 divided by 2 is 30. So on the right side of the equal sign, we'll get 30. And then we just solve. So we have 15 times x. So of course, since it's multiplication, you're going to do division. So we're going to divide both sides by 15. Anything divided by itself is just 1. So the left side of the equal sign is just x. And that's equal to 30 divided by 15, which is 2 on the right side of the equal sign. All right. So let's look at problem C. We have 5x minus 3x equals 30. Let me kind of separate this a little so it's not all bunched up. Okay. So again, we're going to combine everything on the left side of the equal sign. So we know that 5x minus 3x is equal to 2x. Since 5 minus 3 is 2, 5x minus 3x is 2x. So on the left side, we have 2x. And on the right side, it's still equal to 30. Okay. So now since we have the 2x by itself, we go ahead and divide both sides by 2, where 2 divided by 2 is 1. So on the left side of the equal sign, we have 1 times x, which is x. And on the right side of the equal sign, we have 30 divided by 2, which is 15. Okay. Now for problem D, there are no real extra steps. You have negative 14x equals 168. Okay. So with that, you just divide both sides by negative 14. You don't have to do anything extra. So negative 14 divided by negative 14, any number divided by itself is just 1. So on the left side of the equal sign, you have x is equal to 168 divided by negative 14. Now 168 divided by 14 is 12. Positive divided by a negative is negative. And for problem E, I was about to put EX there, but for problem E, the same thing. Okay. So what I want you to do is press pause and try to solve problem E on your own. The 15x minus 10x equals 95. So try to solve that one. All right, so I'm assuming you've paused and solved it. So let's go ahead and verify. So 15x minus 10x equals 95. Okay. So if we combine our like terms, we can combine 15x minus 10x. So 15x minus 10x, since we know 15 minus 10 is 5, 15x minus 10x is 5x. So that gives us 5x on the left side is equal to 95. Okay. So again, first, as soon as we have it combined, we're going to go ahead and divide both sides by 5. 5 divided by 5 is 1. So you have x is equal to 95 divided by 5, which is 19. Okay. And again, remember, if you don't have to do these in your head. If you want to go 95 divided by 5, 5 goes into 9 once. 5 times 1 is 5. We subtract. 9 minus 5 is 4. Bring down the 5. 5 goes into 45 9 times. 5 times 9 is 45 with a remainder of 0. Okay. So again, you don't have to do these in your head. Take a couple of seconds, do them on the right or on a separate sheet of paper. You will be set. All right. So hopefully this was clear and made sense, and I'll see you on the next video.